A simple bar chart is shown here. We will go through the process of determining the critical path by using the critical path method. The first step is to create a simple activity diagram. This involves showing the logic or dependencies between activities. Activity durations are also indicated on the activity diagram. Next, we need to include a space on each task card for early and late start and finish dates or times. Times, rather than dates, are required for tasks where hours or minutes are significant. The early start and early finish are simply the earliest times that a task can start or finish. The late start and late finish are the latest times that a task can start or finish. For this example, we will assume that each calendar day is available for work. In this example, start date the 13th of March, 2025. We also assume that the workday commences at 8 a.m. and finishes at 4 p.m. Starting with the tasks at the beginning of the diagram, complete the early start and early finish for each task in turn, following the arrows to the next task. The early start of a task is the same as the early finish of the preceding task. If there is more than one predecessor task, then there are several possible early start figures. Select the latest of these. The early finish for each task is equal to the early start plus the duration of the task. The final calculation is for the earliest completion time for the project. This is calculated in the same way as the early start date. Let's start the forward pass calculation for determining the early dates. For task number 1, the early start is the same as the project start date. The early finish is equal to the early start date plus the duration of task 1. In this case, the early finish is equal to the 13th of March plus 1 day, equaling the 14th of March. Let's move to task number 2. The early start of task 2 is the next working day after completion of task 1. As task 1 finishes on the 14th of March, the next available workday is the 15th of March at 8 a.m. Therefore, the early finish of task 2 is the 15th of March plus task 2 duration of 3 days. The early finish of task 2 is calculated as the 17th of March at 4 p.m. Let's move to task number 3. The early start of task 3 is dependent on task 2, the next working day after completion of task 2. As task 2 finishes on the 17th of March, the next available workday is the 18th of March at 8 a.m. Therefore, the early finish of task 3 is the 18th of March plus task 3 duration of 4 days. The early finish of task 3 is calculated as the 21st of March at 4 p.m. As the project finish is also dependent on the completion of task 5, let's now look at the second chain of logic-linked tasks. Let's look at task 4. The late finish date is the preceding workday to the start of task 5. In this case, the late start of task 5 is the 14th of March at 8 a.m. Therefore, the late finish of task 4 is calculated as the 13th of March at 8 a.m. The late start of activity 4 is equal to the late finish minus the task 4 duration of 1 day. The late start of task 4 is the 13th of March at 8 a.m. Let's look at task 5. The late finish date is the preceding workday to the start of task 3. In this case, the late start of task 3 is the 18th of March at 8 a.m. Therefore, the late finish of task 5 is calculated as the 14th of March at 4 p.m. The late start of activity 5 is equal to the late finish minus the task 5 duration of 1 day. The late start of task 5 is the 14th of March at 8 a.m. Let's look at task 3 again, as it has 2 predecessor tasks, task 2 and task 5. The early start of task 3 is the later of task 2 early finish or task 5 early finish. In this instance, task 2 early finish was the 17th of March at 4 p.m. and the 14th of March at 4 p.m. for task 5. Therefore, the early start of task 3 is driven by the completion of task 2, being the 17th of March at 4 p.m. confirming that the early start of Task 3 is the 18th of March at 8 a.m. Let's look at Task 2. The late finish date is the preceding workday to the start of Task 3. In this case, the late start of Task 3 is the 18th of March at 8 a.m. Therefore, the late finish of Task 2 is calculated as the 17th of March at 4 p.m. The late start of Activity 2 is equal to the late finish minus the task, 2 duration of 3 days. The late start of Task 2 is the 15th of March at 8 a.m. We have now completed the forward pass calculations and have confirmed the early project finish has been determined as the 21st of March at 4 p.m. We will now undertake the backward pass calculations. Starting with the tasks at the end of the activity diagram, calculate the late start and late finish for each task in turn, following the arrows in the reverse direction to the previous task. The late finish is the same as the late start of the succeeding task. For the final tasks in the project, this is equal to the earliest completion date. If there is more than one successor task, then there are several possible late figures. Select the earliest of these. The late start for each task is the late finish minus the duration of the task. Let's look at Task 3. The late finish date is the same as the project finish date. In this case, the late finish of Task 3 is the 21st of March at 4 p.m. The late start is equal to the late finish minus the Task 3 duration of 4 days. The late start of Task 3 is the 18th of March at 8 a.m. Let's look at Task 1. The late finish date is the preceding workday to the start of Task 2. In this case, the late start of Task 2 is the 15th of March at 8 a.m. Therefore, the late finish of Task 1 is calculated as the 14th of March at 4 p.m. The late start of Activity 1 is equal to the late finish minus the task, 1 duration of 2 days. The late start of Task 1 is the 13th of March at 8 a.m. Let's look at Task 5. The early start of Task 5 is dependent on the finish of its predecessor task, Task 4. The next available working day is the 14th of March at 8 a.m. The early finish of Task 5 is the 14th of March plus Task 5 duration of 1 day, equaling the 14th of March at 4 p.m. Similar to Task 1, Task 4 early start is the same as the project start, the 13th of March at 8 a.m. The early finish of Task 4 is the 13th of March plus Task 4 duration of 1 day, equaling the 13th of March at 4 p.m. Let's calculate the total float for each task. The total float is calculated as the late finish date minus the early finish date. Do this calculation for each task. The results show that Task 1, 2, and 3 all have 0 days total float. Task 4 has 4 days total float, and Task 5 has 3 days total float. We have now determined that the critical path goes through Tasks 1, 2, and 3. We have identified that Tasks 4 and 5 have float and possibly could start or finish later, or have increased durations within the total float without impacting the project finish date. Let's look at the late project start date. The late project start is dependent on Task 1 and Task 4. The driving task is the task with the latest start date. In this example, Task 1 has the earliest late start of the 13th of March at 8 a.m., but driven by Task 4 late start. The project start has a late start of the 16th of March at 8 a.m. Understandably, more complex schedules would take considerable time in calculating the critical path, using manual calculations. Our assumption of every day being a workday has also simplified the calculations. Likewise, our assumption of an 8-hour typical workday. CPM software makes this fast and more accurate. However, the basic fundamentals of CPM need to be clearly understood to understand what CPM software is telling us.